right, Spec is infra. Let's go. So for the longest time, I don't know, maybe 10 years at least, this is what peak software engineering looked like. See this dude? He's focused, determined, maybe even knows what he's doing, head out. But it's becoming increasingly clear that this is not the future. This is. So this is basically me last night at 2 a.m., but for some reason, I still have my keyboard at the desk. But my question now is what can we do to make this depressing future happen sooner? So I'm Yury Selivanov. I'm Python core developer. I worked on async await, added context vars to Python, helped a bunch with async IO, shipped UV loop. Lately, I'm wondering how to ruin Python typing once and for all. CPAP 827. I'm super excited about this one. I'm director of engineering at Vercel, and in my past life, I was founder of Gel. Problem. LLMs are pretty much science fiction. But managing context for them makes them dumb. And it makes us dumb too, right with them. Because we've all been here, we've all been there. The agent just like loses the context as you go, and you have to restart the session. So we are trying to basically manage the context and scope with agents.md or Claude.md and like lately skills. But the thing is, that stuff just doesn't scale. Design decisions get forgotten, business logic isn't documented, agents hallucinate context, and they can search for stuff. Like, why is that? Well, the problem is that software is actually incredibly complex. You have a lot of files, complicated logic encoded in multiple different places in those files. You have hard to trace dependencies and weird side effects, and sometimes within the thousands or millions of lines of code, encoding your ideas and business logic and tests and hacks and backdoors, like all of that is there. It's just like hidden in the code. And we really want to map and like harness all of this complexity, just like with a couple of text files. I think it's just naive. So what can we do? So arguably, I think it's easier to map something that looks like a graph to a graph. And this is, I think, where the next phase is heading. From flat files, we'll be going to graphs, or knowledge graphs, more specifically, where we can compress the knowledge and make it so that the knowledge of your system is evolving in parallel with your code. The knowledge is a condensed, reviewable, addressable form. That should actually drive the agent, not a couple of English sentences and it researching your code over and over and over again, every single time, like it's seeing it for the first time. So how do we build the knowledge graph? Well, we have to start with the requirements for it. It must be easy for humans. Whatever system we end up with must be readable by humans and agents and must be reviewable by both agents and humans. It must be easy to contribute new things to it. And it must be somehow verifiable. Like you have to keep the agent in check with what it does there. And that's pretty much it. There are no other requirements to it. So here's a thought. Humans like Markdown, some of us use Obsidian or LuxSec or Rome Research. We obviously like hyperlinks a lot, like the web wouldn't happen without them. So what if we could provide a system to compress the domain knowledge of your application or system or product into a graph of Markdown files? We then can actually define the workflow and the tooling to enable this graph, make getting the knowledge from it and contributing knowledge to it easy. So welcome to Agent Lattice, or I call it lad.md. You can open it on your phone if you want. It's a real website. And a couple of things. First of all, this is not a Vercel project. This is like something that I'm building on the side. But the system itself is built with itself. It's self-hosted. So there is at least one thing that uses it successfully. So funny enough, this project started as a lunch conversation when I was yapping around the hypothetical future of programming, like what it will look like. Like, will we have much more high-level programming languages where we can express business logic and concepts somehow without like implementing the algorithm itself, bugging with the details of that, and then I realized that English is that actual language. Like, programming languages are great at describing algorithms. English is great at describing real high-level concepts. So what are we building? So we're going to have a new directory, lat.md, in your project. You will commit it to the repo. And it will have the markdown files. We're going to borrow the hyperlink syntax from Obsidian. So this is markdown plus this little extension. In square brackets, you can specify either the local section or a section in another file. So you can have links. You can navigate it. And then I also want to have backlinks from my actual code base. I want to annotate which potentially section of my knowledge graph this particular piece of code or this particular class or function references. And then we're going to build tooling around it. So the first one is going to be lat init. So you can open a repo that already exists, or maybe you just started a new thing. You type lat init. It will create the lat.md directory for you, set up the gitignore files and everything else. Most importantly, it will adjust, it will generate agents.md and claude.md files for you, teaching the agent how it should work with the knowledge graph. And then there is some low-level tooling that the agents and us humans can use. So the next one is lat refs. This one this one expects a essentially section hyperlink. And then it will find all the sections that reference this section within your knowledge graph or within your code base. The next one is lat locate. This one allows the agent to find the actual section text by the reference to it. So like it encounters something in the code base, it can quickly call lat locate and find the actual thing within the knowledge graph quickly. And remember, those things can be complicated. You can have directories, you can have files, multiple nested sections and whatnot. So you have to give the agent a way to navigate this thing without resorting to grep. The next one is lat search, and this one is interesting because the system basically builds the rag out of your Markdown knowledge base. It does it automatically as you go. You only need to specify the API key of your LLM provider and gateway. And it will do it for you. Automatically create libsql file and just do it fully locally for you. You can prompt the system, tell it what you're looking for, and it will find the closest matching pieces of knowledge within your Markdown knowledge graph. The next one is let prompt. So this command actually can be used by the agent to pass through your prompt that you are typing in your open code instance or Claude instance, doesn't really matter. It will pass your prompt through it, and it will basically expand the references in square brackets that you can mention in your prompt to proper locations within the knowledge graph. And if it cannot do it, it will prompt the agent to enter in the loop to actually resolve those references. So for example, you can tell Claude Code, hey, I want to implement, and then you specify user in double brackets to do a certain, to be able to do a certain action, and then in double brackets you specify the page on your website where the section should be performed. And then the agent would be able to pull the knowledge about those concepts and enhance its own context for this specific coding section. And the most important command of all of them is lat check. Lat check actually verifies the internal, the integrity of your knowledge base, that all links are correct, that the Markdown syntax is fully correct. But then we can also build tooling around this concept. So if we say that in our project, whenever the CI is run, you obviously run your tests, but then you also always run lat check. And then you can do some little interesting tricks with your Markdown. So for example, we can have, I apologize, the contrast is probably bad, but Markdown has this thing called front matter. As we all know, you can specify basically like a piece of little YAML in it with additional config. So LAT takes advantage of that. It specifies, it has a special key, which basically is require code mention true. And when this key is specified, then every leaf section within the Markdown file must be linked from the code base somewhere, at least once. So this basically gives you a neat way to organize your tests and keep them in check. So basically, you can have a directory within your knowledge graph, call it tests, load a bunch of files there, functional.md, mock.md, whatever you want. Every section in those files can be describing a test. You specify this thing, and then the agent will be in check to actually give you a test implementation for every test idea that you have. And you will not be able to regress, because like if the test gets dropped or anything like that, lat check will instantly complain. So like the agent will have to bring back the test. So it keeps the two things evolving side by side. This is an example. This is the part of AGENTS.md that generates. I'm not asking you to read it, although you probably will. But basically, it tells the agent that it should use let search and let prompt every time you are building something new, just to enhance the context of your current coding session, the beginning of it. Then it also instructs the agent to always update let.md files if you're adding something new to the system, or review it, run let check. This is important to keep all things in check and all things correct. And obviously, don't skip this test or you go to jail, right? So the idea here is that agents are actually surprisingly good at maintaining the knowledge graph. Somehow, this concept is natural for us humans, and it's natural for agents too. Like in my experience using the system for a couple of like little toy projects, it actually did a very decent job at gradually building the knowledge base of the project as I was building it myself. I have to prompt it at the test, and then it adds the actual implementation of the test and specify by itself, based on this guidance, it specifies this test in plain English, like what it actually does. And the interesting thing here is that then you can ask another LLM to review it, maybe like a month later or whatever. Or maybe you do it in CI, continuously reviewing, hey, does my spec match my production code? You can fast test this. You can have an instrumentation where in CI you pick 5 random tests or 5 different concepts from your knowledge base and ask the agent to verify it and take a look at the code base, identify problems with it. So you can actually automate now the conformance of your code, which can potentially be extremely complicated, to the knowledge system that you specify. And again, agents appear to just like happily follow this. Actually, it was kind of funny. Like last night, Claude thanked me for introducing him to lat.md, which is kind of like the first sign of AGI. Like that was super surprising. So agents are happy, but users can be happy too. This is actually quite cool, but because lat.md is Markdown plus Obsidian syntax for specifying links, you can actually open it in Obsidian. And then you can browse your own knowledge base easily with this. You don't have to build any UI for this. You don't have to deal with Markdown files yourself. You already have the UI for it. Just download the free application and use it and review it. So again, the whole point here is that with AI, we're going to see 10x, 100x, some crazy number x multiplication on the amount of the software that we produce. It's not going to be possible for us to review the code. It's like we wish we could, but the reality is that none of us will eventually. The LLM will produce a crazy amount of code, 10,000 line diff. You will not be able to review it. It's just impossible. for anyone to do that. You either use this thing sparingly or you go all the way. And most of the companies, most of the businesses will go all the way. So if you want to compete with them, everything will accelerate. So I argue that it's easier to review 20, 30-line diff for Markdown files specifically in your knowledge base than to actually review all of the code that is just spit out. So anyway, this is it. I really want you to try the system. I want to get some feedback for this. The installation is pretty simple. It's npm i.g.latmd, and it will just install it, or you can use npx, although be careful. It tends to use older versions without telling you. Then you just run lat init. You can actually do it in your existing project if you want, or start a new one. In an existing project, if you already have agents.md or claude.md, the system will detect it and will tell you to run lat gen agents.md command manually, and then you can just merge by hand your files, or ask, better actually to ask your agent to do that. And off you go. The system is fully bootstrapped for action. So share with me your complaints and success stories. I'm first one on X and GitHub. Thank you.
What questions do we have for Yury? I might actually just hand the microphone for questions, so I'm going to float this around the room. Please go ahead.
Thank you very much. I had a question about something you mentioned with lat check, where if a test is changed or disappears, then that should catch it. So lat's also updating the knowledge graph. What happens if the leaf is deleted somehow, and then that test is deleted? Is there a way to track that kind of drift?
Then it's gone. Yeah. Potentially, we can build additional tooling for this, or maybe it's solvable with instructions. Like, for example, we can build either a separate agent or a separate step within agents.md. Hey, look at the diff, at the git diff, before we commit it. Analyze what was changed in the knowledge graph and reason about it being necessary or not, or highlight the change to the user. For what it's worth, like in my own experience, Claude, for example, wasn't exactly good at following all of the instructions, and sometimes it just skipped. But somehow something changed, and like with Opus 4.6, it's actually quite decent at following what you do, at following the procedure. Where it can't, you can actually script it with things like lat check and whatnot. But I expect that ultimately the consistency will only improve. Like maybe they will still not be able to write complete products from scratch without any input. Maybe that's unachievable in the short term. I don't know. But the stickiness of them, of the workflow to the process that you outlined, I think it's improving day by day, essentially. So I'm optimistic.
Thank you. This looks very interesting. This might be too intensive for lat check, but can you imagine a tool that is finding inconsistencies within your code base that, for instance, at one place something is assumed and at another place something else is assumed?
I think there are like two ways of doing that. Like either you do it or you somehow tell the agent to do it. You doing it is completely impractical, I think. Again, the beauty of the system is that the knowledge is ultimately there, so you can basically just point agents to it continuously, potentially, just like continuously improving the code base. Just let them rip through the knowledge base and check the code conformance with it. This obviously needs to be tested, but like at least now it can be automated. Unlike your, I don't know, random chats with Claude Code where the history is ultimately lost after the feature is committed. Here you have the actual artifact of knowledge in the system. So arguably, like this should be an improvement where you can actually script this and automate this. Whether it's possible to do efficiently for large-scale projects, not like a 10,000-line application, but for something with like hundreds of thousands of lines of code, I'm not sure. But I don't know. Again, like LLMs are improving really, really fast. If we're going to be trusting them with developing those systems in the first place, I think it's not unreasonable to assume that they can also trace Markdown files for you and check correspondence.
Right, so you could have, like, besides your one that is doing your current task, you could have another one.
Of course.
Continually in the background, looking for all the bugs and inconsistencies. Thank you.
Of course.
It's pretty amazing that you're able to capture knowledge graphs in a Markdown. The traditional mechanisms like Neo4j and knowledge graphs are pushing for knowledge capture in true graph databases. In my mind, they also still don't quite cut it in full knowledge representation. A single file being hit by 10,000 users, you get a Cloudflare-like file failed kind of a thing. So what are your thoughts moving forward in improving the implementation of Markdown itself and making more robust for concurrency and simultaneous queries?
Yeah. So again, like here, you can have multiple Markdown files, and I have a little bit of database background. So naturally, like when I had this thought for the first time, I was like, maybe we can use a like proper graph database for this or Postgres. But then you have to build UI for this. You have to automate this. You basically have to build a lot more stuff around it. For, I don't know, like maybe if you are building Linux kernel with this thing, then maybe you need a graph database and like a proper like knowledge service, essentially. And I'm pretty sure that this might be where the system evolves eventually, not LatMD, but like the industry. Maybe we will have those knowledge systems as part of your engineering infrastructure. But for now, we have to prove that this concept works at all, basically. And for that, I think just a collection of Markdown files with basic tooling to verify self-consistency should be more than enough.
Let's thank Yury again.
Thank you so much.